Welcome! This is a lesson on the equations of circles. By the end of our lesson, we will be able to identify the radius and center of a circle from an equation, and we will be able to write the equation of a circle if we are given a center and a radius, a center and a point on the circle, or the endpoints of a diameter. The equation of a circle that we will be using is this here, the quantity x minus h squared plus the quantity y minus k squared equals r squared, where h and k are the coordinates of our center of the circle, and r is the radius. Let's get started. Write the equation of the circle with the given center and radius, then graph the equation. So we know that we have x minus h squared plus y minus k squared equals r squared. H and k make up the center, so h comma k, and my radius is 4. All we need to do is plug these values in. X minus 0 squared plus y minus 0 squared equals 4 squared. But we can actually simplify this more. So x squared plus y squared, because y minus 0 is also just y, equals 16, which is 4 squared. And now we need to graph this. To graph it, start with your center and plot that point. So 0, 0, and a radius of 4. From your center, count 4 boxes up, down, left, and right. Up 4, down 4, left 4, right 4. So all 4 of these points are going to be on our circle, and we're going to connect the dots. We are not going to use straight lines. We are going to use a curve. A straight line would give us a rhombus. We want a circle, so make sure you use a curved to connect all 4 of these coordinates. And that would be our circle graph. Let's do another one. Same thing, write the equation and graph it. X minus h squared plus y minus k squared equals r squared. And the center is your h comma k. So plug in the points. X minus 2 squared plus y minus negative 4 squared equals 1 squared. X minus 2 just stays as x minus 2 squared plus, and then y minus negative 4, those double negatives become positive. So this is y plus 4 squared, and 1 squared is 1. That would be the equation of this circle, and now we're going to graph it. Start with the center 2, negative 4, and plot that point. And this has a radius of 1. Up 1, down 1, left 1, right 1. And then use some curved lines to connect them so it looks like a circle. That's all there is to it. Now we're going to go the other way. Here's an equation. Find the center and the radius. So the center, remember, x minus h and y minus k. So we want this to say x minus a number. X minus some value. Well, if it's x plus 1, we want to undo that plus, so we're going to break it into 2 negatives. X minus negative 1. And the y already has a minus, so y minus 2. This gives us our center, h and k, meaning negative 1, 2. our radius. This equals r squared. So r squared equals 9. To undo the squared on r, we square root. So r equals 3. Now graph it. Start with your center, -1, 2, and a radius of 3. So up 3, down 3, left 3, right 3. And now just connect the dots on the outside. There's a circle. All right, let's keep going along here. Here's one just like it. Here we have our equation x squared plus y squared equals 16. Since x and y don't have anything there, they're using the additive identity. In other words, if this is supposed to be x minus h, they are hiding it by putting a 0 in there. And the same thing for y. It's supposed to be y minus k. But since you don't see anything, it's really a 0 in there. So our h comma k for the center, 0 comma 0. And our radius, this is still r squared. So r squared equals 16. So we are going to square root each side. R equals 4. So plot the center, 0, 0, up 4, down 4, left 4, right 4. There's our circle. So that's the basic type of problems. Here's an equation, find the information and putting it on a graph. But what if our information isn't as friendly as that? For example, this. Here we're given the center 8, 4, and we're only given 1 point. It doesn't tell us the radius, it doesn't give us the equation. So we are going to start the same way. Plot your center 8, 4. And now it tells me that point 0, 4 is on the circle. So I'm going to plot this point 0, 4, and that's on the circle. Now to help me keep this in perspective, I'm going to sketch a circle very, very roughly so I know which point's the center and which point's on my circle. So I've got a circle that comes around like this, and it goes around that center point. This helps to visualize what's happening in the problem. We can start our equation because we have h and k. So we can plug in the center. X minus 8 squared plus y minus 4 squared. What we need to find out is the length of r. Well, a radius goes from the center to a point on the circle. So I can actually connect these 2 points, and that would be my radius. But in order to find it, we are going to have to calculate the length. Since this segment is horizontal, it goes straight across the grid lines, all we need to do is go ahead and count the boxes. So when I count from one point to the other, this has a radius of 8. So this would be 8 squared. And then I'm just going to rewrite my equation in simplified form. So x minus 8 squared plus y minus 4 squared equals 64, because 8 squared equals 64. And that's all we need to do for this problem. Okay, here's another problem. The center is at -2, 1. So I'm going to plot that point, and it tells me that 1, 0 is on the circle. And I'm going to plot this point. I'm going to sketch this circle out so I know what is happening in the problem to help visualize. So I can now see the circle, I can see the side of my circle. We know that we can start our equation. So I'm going to go ahead and do that. Because we already know the center. So x minus -2, and that's squared. And then y minus 1, and that's squared. But now we're down to the radius. When I connect these 2 points to form my radius, this is not going horizontally across or vertical up and down. It's on a diagonal. So we're going to have to calculate the length of this segment, or the distance between the 2 points. Remember, to calculate distance, we can use the Pythagorean theorem. So to find radius, we need to use Pythagorean theorem. Which is a squared plus b squared equals c squared. First thing we're going to do is draw in the right triangle. Draw it in, count the boxes. So it's 1 high and 3 across. Those become the A and the B because of the sides of that right triangle. 1 squared plus 3 squared equals c squared. All I'm going to do is solve for c. So 1 plus 9 equals c squared. 10 equals c squared. And then square root. Square root 10 equals c. This c is your radius. That's what we were calculating. So radius square root 10, and it's radius squared. Now I'm going to go through and simplify everything I can. So I have a double negative with the x, so x plus 2 squared, and then y minus 1 squared equals the square root of 10 squared. The square and the square root undo each other. So these cancel each other out, and you're left with just 10. So that works out very nicely on how those kind of eliminate one another. Let's do another example, but I want you guys to start this problem off first. -5, 1, and the point -2, 5. And this is what your circle looks like. It's something similar to this. So go ahead, plug in the values, and don't forget, use Pythagorean theorem to find your radius. Alright, go ahead and get started. Hit pause on this video. Alright, let's get started. Alright, let's go over this. So x minus h squared plus y minus k squared equals r squared. I'm going to plug in the center, x minus -2 squared plus y minus 5 squared. And now we need to calculate r. So I'm going to connect the center and the point on my circle. And that's my radius, and this is on the diagonal. So I need to use Pythagorean theorem. Draw in the right triangle, and then count the boxes. Those lengths become the A and the B in the Pythagorean theorem. So 3 squared plus 4 squared equals c squared. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25 equals c squared. And we are going to square root each side. 5 equals c. This c value is your radius. So I'm going to take 5. I'm going to put it in for r. And then I'm going to square it. Now all we need to do is simplify. Find all your double negatives, turn them to positives. X plus 2 squared plus y minus 5 squared equals, and 5 squared is 25. All right, that took a lot of work, but great job. Here's a slightly different type of problem. This problem gives us the endpoints of a diameter. So -6, -4. And then -6, 8. So these are the endpoints of a diameter, which means these are both on the circle. So my circle goes something like this. So we know we need a center and we need a radius. The center of the circle is going to be the exact midpoint between the two endpoints of my diameter. So you could use the midpoint formula here. Midpoint formula says add the x's, so -6 plus -6 over 2, and then divide. It's just finding averages. So -6 plus -6 is -12 over 2, and this is -6. And then do the same thing for the y values. -4 plus 8 over 2. Add them and then divide by 2. -4 plus 8, +4, divided by 2, is 2. So these points here make up the center, -6, 2. And I can go ahead and plot that on my graph. So I have the center. Now I need the radius. Remember, the radius goes from the center of the circle to any point on the circle. But both of these endpoints are on the circle. So I will connect my center to one of these points. And I've noticed that this is an exact vertical line, which means I can just count the boxes. So between the center and the outside point, I have exactly 6 boxes. So my radius equals 6. R equals 6. And now we can write our equation. X minus h squared plus y minus k squared equals r squared. X minus -6 squared plus y minus 2 squared equals radius squared, 6 squared. And then simplify. And this is the equation of that circle. So here you just want to make sure you remember, use that midpoint formula, which is just adding and dividing by 2 for your x's and y's, finding averages, and then plug in the information. Right, here's a different type of problem. Which of these 3 options is going to be tangent to these 2 circles here? So what we're going to do actually is just go ahead and graph all 3 circles, and tangent means that you touch in exactly one spot. So on option A, we have a center of 0, 0 and a radius of 5. So I'll go ahead and plot that. A 0, 0 and a radius of 5. Left, right, up, down. When I sketch that circle on there, this circle is not tangent because it is crossing into each of these circles. For it to be tangent, it would touch in exactly one spot. So this is not an option. Cross it out. Option B, we have a center at 5, -5, and a radius of 5. So here, 5, -5 and a radius of 5. Left, up, right, down. So this circle is tangent. So we know that this one is tangent to it because it touches the blue circle and the green circle in exactly one spot. All right, now the last problem. X squared plus y squared equals 100. This has a center of 0, 0, and a radius of 10. So here's my center, and then I'm going to go 10 up, 10 left, 10 down, and 10 right. Connect them. And we again see that this circle we just sketched on here, it's crossing through the centers, the middle of each, the green and the blue circle. So this also is not tangent because tangent only touches, it does not go through. So we can cross that one off as well. So on this problem, the only circle that is tangent is option B. All right, let's just wrap a few things up. So don't forget the equation of a circle is x minus h squared plus y minus k squared equals r squared. The center is your h comma k and your r is your radius. And then a few other things just to keep in mind. You may need to use your Pythagorean theorem to find your radius, and you might need to be using the midpoint formula to find the center when you're given the endpoints of a diameter. And that's all we have for this lesson.